Did we have the countdown? Oh, great. Wonderful. All right. I'm just going to do a quick administrative intro and then
Mhm.
we'll get started. Hi, everybody. Welcome back. I'm Eric Postow of Holon Law Partners. With me today is Merve Yildiz, a particle physicist turned AI engineer and strategist. Welcome, Merve. Thank you for joining me here at Holon for a nice conversation on AI and you.
Thank you for inviting me, Eric. Pleasure to meet. Pleasure to be here.
Absolutely. So, Merve, I just want to kind of start by catching us all up to now. So, I want to going to go back in time and then see how did you get to now, because it's such an interesting
Mhm.
concept. A particle physicist turned AI engineer. One might not associate particle physics with AI engineering or technological computing or anything like that.
Mhm.
And so I think that that's an interesting move and evolution of you to explore. But I want to start with you are a very well-traveled person, grew up in Turkey. You now reside in London,
Yes.
and you come by way of Korea,
Yes, that is true. That is true.
and you have studied under some great educators in both the physics space and in the AI technological space.
Mhm.
Um, how did you get to now?
Well, it's kind of like a long story, but let's try to keep it short. So I was always into astrophysics because of the reason that my last name means star in Turkish. So that fascinated me from the childhood, and I think that had like a huge impact on my whole education. And I wanted to become an astronaut, but then I realized that maybe astrophysics might be more interesting, and that's why I get into the space of physics. Later on, that while studying in physics, I realized that the astrophysics is actually quite old, especially back in the days like 2013, 14. We didn't really have much of experiment going on, so the mainly the experiments were funded was on particle physics, and because the field was old, so I became more interested with the particle physics space because it was high energy particles and there was a lot going on. They just discovered Higgs, and there was a lot of opportunities out there.
When you say Higgs, that's Higgs boson.
Yes,
Just for
that
what is that?
So that's basically a property on subatomic particles that's kind of associated with attracting mass.
Attracting mass. It's a
Yes,
particle that attracts mass.
yes, we can
In a
say
very
that.
simple, I'm a simple person.
Yeah.
So in a simple way, that's what it is. I'm sure in a particle physicist way, it's a much more complicated thing.
And then the way that how that was actually discovered is basically through bunch of data, like data collected for years over years, analyzed by many physicists, and then during that analyzation, the methods that we use actually to detect something with kind of like confidence that this thing exists, something that we don't even see, is through data and analysis. While we are doing these analysis, we are using methods, and we can call this curve fitting. And these curve fitting are is actually on this at the center of machine learning space, and they are very well connected. So transitioning from a particle from a particle physics perspective, transitioning from there to become an AI engineer wasn't that hard because we were already doing using machine learning techniques when we were discovering this kind of particles. And also, when it comes to becoming an AI engineer, the most of the important part is the data and the data sets. So you need to know a lot about statistics, and you need to back yourselves up with the statistics to understand what's going on in the data space. So I must say that as a physicist, it was almost like natural to go into the AI space for me.
Hmm. And what does it mean once so now you've gone from the particle physics space, you're using large language model machines.
Mhm.
That is how you learned about the machine side of that, the technological side. And then you pivoted into full-time that. Tell us about that.
So basically, after I finished my master's degree, I wanted to do something more about neuroscience and the brain and how the brain works, because I was always interested in neuroscience as well as physics. So I wanted to do something with the brain and understand the brain and how it functions. So I started to do an internship in a company, which I was working on a project for epileptic seizure forecasting. So basically, there was a data set that was coming from open brain surgeries, and we take the data, analyze it, and try to make an AI that will forecast whatever the like whenever the epileptic seizure is going to come to a patient. So that brain, and we, obviously we were using AI system. That project made me really interested with the how the brain works, and whether we can actually use some techniques to understand the intelligence and the consciousness and all that beyond after. So that's why I was okay. I made my decision. I was like very interested in, and later joined the startup that I was doing the internship and get into the AI space. And that was in 2019. And at that time, we didn't have LLMs. So we basically have NLP, that at the time it wasn't like a big deal, and we only have like object detection networks that were basically detecting objects with like a funny like rectangular shape. So at the time the things weren't as heated as now, but still with the precision that we have, we were able to solve a lot of different problems. um, yeah.
So you're talking now about the kind of the pre LLM
Space.
moment, and what was the primary change? What made LLMs a thing?
Mhm.
What was the problem that it solved?
Well, I think from the for me the moment of like, okay, we had curve fitting from 1950s. We were using this like techniques for so long. It was always there. It was being used for different like problems like physics, or different problems in finance like predicting the market analysis and stuff. When did it became actually like sparked and everything started to change is, I'm going to say, in 2017, there was a paper published called Attention is All You Need. And it was basically introducing a new method called transformers. So these transformers were a tool to tell you what is relevant in the input data that you were giving. So it's called, there is a method used in the transformers called the attention mechanism. So basically, this mechanism made it possible for the models to scale on a very big, impactful way. And that is where I believe things started to change, because LLMs are using transformers. So many models that we are seeing right now, most of the generative models we are seeing right now are using transformers. So transformers were a like pivotal moment in the history of AI, that I think take all of what we have and bring it us here.
So the transformer apparatus or process,
Let's say it's like a method.
it's a method,
Yes.
and in this method, it's what taking the volume and making it usable. What's it doing?
So the method itself, it's almost like, okay, there is when we are talking about neural networks, we are talking about two things. One of them is the architecture. of the neural network, and the other one is the data, or like the weights that the model has. So basically, once we show the data, we train the model with the data sets, then we have weights. These weights are actually the things that are going to determine like what the model actually learned. These are basically almost like chunk of little like magical numbers that's storing information. And without the weights, that architecture is not doing anything. So while this training happening throughout this, like when I am showing data to an architecture to get weights, I am using different methods. So I am showing it, and then how can I say, I'm showing it, and then it's doing a lot of calculations on the background. What transformers basically introduced was the idea of relevance in the input data sets. What I mean by that is that I'm gonna know if I'm showing, let's say, a picture with a dog carry, I don't know, a picture, a person with a dog. Is there a way to understand the human is which human is the owner of the dog? If there's, let's say there are two people in the picture, one person is closer to the dog, but it's actually not the owner, it's just passing by closer. The other person is on the background, but it's actually the one who is owner of the dog. And then you can understand with the maybe because the person is looking at the dog. So the
So
relevance.
it's capturing the subtleties in an observation. So it sees a scene, and there
Mhm.
are subtleties within that scene that give away, they're the poker tell or whatever, that give away some kind of ownership meaning. So it's making meaning of happenings.
It is giving attention to the which part of the picture is like related with the other picture. If I can give another example as a sentence, let's say I'm saying she drank the coffee because it smelled good, and that it is actually, when you take it as one word, it is like it is independent, and you need to understand on a contextual basis that it is actually the coffee, right? So this mechanism give us the relevance, give us like a more general understanding, so that I can actually relate one word with the other, so that I know that it actually is coffee. So this is kind of like a method to for the networks to understand what is relevance in the input that I am giving, which input, which part of the input is like related with the other part of the input, which are irrelevant.
Yeah, this is really interesting stuff, because then that kind of allows you to understand that one of the most important variables are the rules or the describers,
Hmm.
the way the emphasis placed, the meaning of words,
Hmm.
that comes from somewhere. It comes
Hmm.
from someone, or a group of someone's, or a collective someone's. What is the someone that's driving the meaning of any word or any context or anything? So it could be as, you know, non, uh, could be very regular, like looking at a cat, some kind of thing, or it could be more nuanced about intentions of people,
True.
or historical meaning of something.
Hmm.
Do you get where I'm going?
I hear what you're saying, Eric. This, I'm just gonna say, the this method of transformers obviously had a huge impact because of the way that they almost like, so we were able to focus where we need to focus, so that the rest of the data became irrelevant. So I'm gonna ignore that, and it's because the data sets are very big. So I was getting rid of all the irrelevant data set. I wasn't passing them through the network. So that made it easy when it comes to scaling this machines.
Yeah. Okay. So that was a little tangent, but so that was the pivotal moment, and
I,
then
yes.
you moved into. I know you ended up in entertainment and film. Is that the line that you took, or what were the other steps along your journey?
So yeah, I spent 3.5 years in Korea working in that AI startup, and we did a bunch of different projects for like different industries, from finance to medical care and all that. And then later on, I realized that it was for me time to probably like focus on a more specific area to use all the things that I learned, because while you are changing a lot of domain, like every 3 or 4 5 months we used to learn a different domain, which was actually super fun. So I decided that I wanna like focus on one thing and then get into more visual space, because that's where what that was interesting for me. And then I became interested with CG and like computer graphics, and I was like, okay, I want to make my contribution on that like production space, and then joined in a visual effects company in London, and moved to London from Korea.
Wonderful. So that brought you to London and visual effects and film. And what year was that you started in the film industry with AI?
2021, I believe.
And
Oh,
and when you got there, when you
uh-huh,
got into the space, and now you're working with the creatives for films,
uh-huh,
what was the landscape like of AI use? And then if you could kind of explain how it has progressed since
uh-huh.
then.
Yes, I'm gonna say, I mean, the movie industry is very old, and I was the very first AI engineer they hired in the whole company. We're talking about an international company of like maybe 8,000 people, and I was the only one who were even like understanding what AI means in the company. So that was very interesting, because
Did you
nobody.
feel like you were speaking a different language?
Definitely, yes.
So you had to educate them on what it was holistically, organically. Like you had to. They didn't have any comprehension of it, and then you're the one that's explaining it and then showing what
Mhm.
can be done with it.
Yes,
So
and
the
then
application.
yeah, at that time, like nobody is really interested, because like ChatGPT wasn't there, like wasn't a big thing yet. Like nobody was actually paying attention. So it was like I'm telling AI, and they're like, okay, like we're hearing the word, but it wasn't even like a buzzword back then. So I needed to basically try to tell them like what it is and what it can do, and then but also there was like a big resistance in the industry, because everything is very old and they are very used to do things in an old way. So I basically fight for what I believe that's gonna make a difference. And then the moment that I actually had the chance to like like do work with a department, which was the data department, I started building tools for them, and then we kind of like changed the tools and the ways that they are doing some processes. So basically, the way that how they were functioning changed very drastically. For example, after they go to the on-set state, and then they take the data from like the sets, and then they basically organize these data, which probably like takes up to 4 days for a team of four. And I made a program that will do that in like 3 to 4 hours for them. So changing the landscape, and then after showing that work, and then
So that was an efficiency concept. There was processes that you sped up the time to completion.
yeah,
And the
speed up
results were the same or better, or
the
they were
results.
happy with them.
The results were better because of the fact that like a human can get tired while looking at images, and then when they are trying to like put them into categories, but like machines doesn't get tired. So the precision was higher. And then yeah, basically we changed like the pipeline of the data team a little bit, and then show them that this is something AI can do. And then after seeing that, like all the other departments start getting excited because okay, like this is a huge um, difference on the way that how we function and work. And then they were like, okay, what can you do for my department? So
And what did you do? What were
um,
what were all the if you're looking back now and just saying this thing, this thing, this thing, these are the things. What is
mhm.
that?
So we look into very different topics. Like, for example, we look into basically scanning a 3D environment and building that into the like in a computer.
So creating the virtual world, they
Yes.
they take the 3D environment, they scan that, and then it's in the virtual world, and the AI is doing. Did that made it or what?
So basically we done a lot of research. So it depends. I'm not, how can I say this? So it depends on where we are using this technology or what is it used for. For example, if I want to use it for a final shot, it might not be as precise as what I'm looking for. But if I'm just going to use it as a background, and if it's not going to be like it doesn't have to be super consistent, then yes, like we were using for almost like bidding on shows and like kind of like planning the exact final shot, so that when it comes to like getting a shot together and then like putting all things together, it was like making the process faster.
Mm, 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 mm. What
And
are some, go ahead.
there's a lot of different research and a lot of interesting topics around creating like graphical assets on a computer system, because everything we see on a CG scene is actually made pixel by pixel, made by artists. And there's like a huge pipeline, and there's like a lot of people um, back in that scene. But then when it comes to like automizing this space, just by looking at it, can I make this a 3D object? Can I actually understand what this like on a 2D picture, because I am showing a 2D picture? Can I make this 3D? Or can I understand how the light interacts with this, like on a computer space, how they interact with the space? And also rendering is another topic. So there was like a lot of different subjects and a lot of different departments. We were like trying to like kind of like have a pick and understand what it can be done. So we did like a report, and like I basically did like a bunch of research and like show them, okay, this is what we can do for this department, and this is what it can be doing, and then this is how much efficiency we can get out of it.
Understood. So in some, leaving that space, the film creation and the visual AI space, where is it now? What is that industry looking like since it's adopted some of
Mhm.
these techniques? Has it accelerated?
I think it's definitely heading to a direction, but the way that how I see that it's not used efficiently, because it's almost like misunderstood in some ways. Okay, we can use it to conceptualize concept. We can like use like Mistral AI or like Sora to just like have an idea. So an artist actually uses day to day to get inspired by it. But as in terms of like taking that and using it on an actual shot, that's almost unrealistic, because there's a lot of different steps. So it's not precise enough to be used on a final shot, but there are tools that can be built for these people, so that the process is actually so much easier.
Mm.
So I feel like it can be misunderstood sometimes, but it's also again like it is going somewhere
That's
because we
this,
are
this
having more.
seems to line up with just user adoption, that
Mhm,
it's at its least efficient use now.
mhm,
But if we believe that its continued use is inevitable, then it will move towards a greater efficiency as a rule. Do you agree with that?
mhm. I do agree with you. Yes, Eric. They need to understand that they need to allow. That's their initiative. Yeah.
So let's leap out of film. So what we've talked about are a few different industries and adoption. We talked about healthcare. We've talked about
Uh-huh.
neuroscience. We've talked about physics. We've talked about film. And we got into visualization.
Hmm.
Outside of that space, what's the world that you see?
Right now in the
Yeah.
AI space,
The
or
one that you're a part of, and the one that you're thinking most about.
hmm, I I believe in the power of AI and how it can actually change the way that we function. And I don't see it as an extra tool, but rather, can we actually extend how we function, almost extend our brains with these tools, like almost embrace them. And for that to happen, instead of scaring people out with, okay, AI is going to take your job, why don't we start building tools that's going to make their life easier? I remember just seeing a post like last week on LinkedIn. A company X, I not X, like I don't know, I don't want to give the name of the company. They do a layout 2 years ago and changed the employees with AI, and they actually ended up on like negative profit. So they are now looking to get this human force back. So there is something human about humans that we are good at, and we are not, instead of trying to replace them, just like build tools for them to make their life easier. Instead, get rid of the mundane tasks. Don't give all the creative freedom to an AI. Like maybe I don't want to give autonomy, like give give a tool to the user, give the autonomy to the user, and let them decide what they want to do with it.
Yeah, I mean that's a really kind of a deeper point. You're getting into philosophical um, and theoretical human concepts. So if I were to extract from that, what I was hearing was that don't view AI as a replacement,
Hmm.
because what you're doing when you do that is you're limiting the imagination, the creativity. You're limiting who people are and what makes us distinct, which really implies that we have to think about what
Hmm.
makes a human being distinct and unique. And you're saying use, integrate the AI as tools to unlock human potential. And
Yes.
that potential is in the things that make it uniquely human: the creativity,
Hmm.
imagination, the problem solving through experience, the application of real world experience into decision making and judgment.
Hmm.
Does that sound, am I getting you correctly?
Yes, exactly, Eric. Because like this is gonna come to the point of we talking about AGI, like artificial general intelligence. We don't have it yet. Maybe we will. I believe personally that we will one day, but there is currently no intelligence that actually they that has the ability to abstract, generalize, understand the task without us telling the machine, intelligence what to do. So this basically, I'm trying to basically say that there is a segment that we still don't understand about intelligence, that making the human human. So let's use this, and then instead of like trying going against the intelligence, try to use that part and like embed it in our own intelligence, and then use it for our own good.
Yeah, I mean that's pretty far out. Integrating all this technology into our own processes, our own thinking, does that at some point create a new form of intelligence?
That's a beautiful question. Because there is a lot of like debate going on around this as well. But I believe there is a, when it comes to thinking about this problem, there is one thing that I cannot stop thinking about, which is our bodies. We are limited in our bodies. So without our body, can I say that I'm a human? I'm not sure. I think, no, like my personal opinion, without my body, I can't say that I'm a human. So if I find a way to extract all the different parts of my brain and put it in a graph and feed a neural network with this graph so that whenever you talk to me or you talk to this intelligence, it's going to talk to this different intelligence. It's not me. So can you actually say that that's me? No, right? Can you say that this machine that you're interacting with, is that me? Even even let's say that that's actually somehow live and connected to my brain. If I put a chip and it's actually exactly working the same way, making the same decision, saying the exact same things that I will say. Let's say I have a chip in my brain and it's that's doing that thing. So it's because I am limited in body. I'm saying that I'm a human. But that thing, the medium of where the intelligence exists, I believe determines whether something is human or not. So if I am in a medium of a, like if I exist on a computer, or if I don't exist in the 3D world that I was born to, I'm gonna say that that's not me.
Yeah,
I'm gonna say that that's not human. So
yeah. That's interesting. That's metaphysical. Also, the distinguishing feature there is you're saying what is or what is not human, but you are not saying what is or what is not intelligence. And
mhm,
that would signify that there's multiple forms of intelligence. So there is an animal intelligence, and within
mhm,
that, there's a human intelligence. There's a plant intelligence. The plants communicate underground through massive networks that resemble
mhm,
neural networks in many ways. Some recent science is validating that plants make informed decisions. Uh,
mhm,
they make choices. They remember um, uh, not to do something. It
mhm.
learns from its past. So this is the ability to make a choice based on information, its own choice, its autonomy. That I think is a really interesting point. And then there's fungi and similar, and the plant intelligences and the fungi intelligence certainly interrelate and communicate.
Mhm,
And there's our intelligence, and we're just starting to figure out how to relate to these
mhm,
other forms of intelligence. And now we're entering in an artificial intelligence concept.
mhm,
What I think is interesting about AI is that it is a convergence um, vehicle. It pulls in, um, all things and interconnects it. It shows the interrelationship. So if you're designing AI through data, you could integrate in plant intelligence, fungi intelligence, human intelligence into a single thing, which could make decisions leveraging decision making from these other intelligence forms. And
mhm,
that's what AI becomes. It's this integrated intelligence thing unto itself, and then it's how it relates back to something. How does it relate back when we integrate the AI back into plant intelligence
mhm,
or into human intelligence? Do the systems of intelligence start making and discerning and doing things differently? And I don't know if anyone can predict that. Does that
mhm.
sound crazy to you? Did I just say a bunch of crazy stuff, or does that sound rational?
No, there wasn't anything crazy about that, I believe. Because yes, like the plants make decision. They make the decision to go towards the water. They make the decision to reach out to the sun. So they do make decision, and then there are different kind of intelligence, maybe, if that's what we're going to call intelligence. So the choices that we make based on the data. So if that's what we are calling intelligence, like making choices with the data, okay, I'm a plant, I see the sun or I see the water, I'm going to do that decision. If that is intelligence, yes, that is intelligence. So when it comes to having artificial intelligence embedded into these systems for us to benefit from it as humans, I believe there is still the mediator of we need a human. Like I am supporting that. And also another thing that I wanted to add to this, that when we are actually dealing with the data sets or when we are training neural networks, we are actually inspired by the natural phenomena that we see or theories that we actually observe. So, for example, so there is a theory of um, perception of color by Land, the founder of Polaroids. So it basically says that the colors are perceptive, and they are actually your brain is actually making that color, and
Mm.
it's not actually the energy coming to the eye. So
Mm.
this is a different theory when we are like observing
So this
color.
is the kind of the aspect of the human brain that receives energy or whatever, filters it into something it
Exactly.
can understand and comprehend, and then that's
Uh-huh.
the visual representation inside the mind. It's not the actual, it's just the representation. Is this basically what you're saying?
Exactly. That is correct, Eric. Yes, exactly. So, for example, observing this, we actually use this when we are training neural networks because we normalize the colors when we are training, like image, for example, image detection networks. We are normalizing the input images with respect to the color so that every color itself is contained in one image. So basically, like using this kind of information or the things that we observe from the world while we are training these networks, they're actually helping us. So there is a different like way that while we are training artificial intelligence, we don't have to make it um, something very strange or something different than us. Actually find a way to use this that we see, how we word, how we perceive, and then embed that system into the artificial intelligence.
Wow. I could go on for hours like this, but I think we need to bring ourselves to a conclusion.
Okay.
Um, when we see what's unfolding,
Mm-hmm.
what's interesting is when you dedicate your time to the AI space, you recognize that you're really just looking at the world itself,
Mm-hmm.
and you're looking at each happening in the world, and then you're saying what happens when you apply this new technology to that thing. And in that way, AI really is, as I see it, a very transformative um, element, perhaps the most transformative element that has ever existed,
Mm-hmm.
in its ability to pull it all together and create something new, which is called emergence.
Mm-hmm.
Emergence of something new, which would, in some respect, be transcendent. It transcends the current state by transforming. The
Mm-hmm.
transformation allows it to to change in such ways that it's totally new. And it's in that world where we have a lot of opportunity to be creative and imaginative. And it's also the world in which that creative and imaginative can be harmful
Mm-hmm.
or productive. So pro-social or antisocial, pro-planet, anti-planet, pro-health, anti-health, all of these things. Um, how do we start talking about it in a way that people recognize the intentionality required and the
Mm-hmm.
choices that are available so that we can create this new world reflecting on things that are important for a healthy place to live, a healthy place for communities, a healthy
Mm-hmm.
place for the plant life, human life, animal life, fungi life, all things on planet Earth as a one uh, organism, a giant holon, if you would. Um, what do you think?
Well, that's a very deep question, Eric. I believe when it comes to using any tool, like when internet first came out, or like I don't know, like the iPhone first came out, like when it comes to taking a tool and then using it for our own good, or the way that how you're gonna use it, it's, I'm gonna say unfortunately, but it's mainly all upon like individuals, right? I am the decision maker of how I'm gonna use this tool, how I'm gonna like benefit from it. And then we have to be intentional. We have to say that, okay, this is something that I can use it for my own good. So we have to be mindful and purposeful, almost like when we are approaching these tools. But obviously not saying that we should not be like, I don't know, like you can just use it, just to use it. That's also fair. But when it comes to like almost preventing the harmful side, it's, as individuals we have to be like, unfortunately we are responsible, so we have to be more intentional when it comes to preventing the harmful side again. uh, yes, we have to have more data privacy policies. Government has to have like some initiatives around data, because data is what exactly makes these neural networks and what makes the artificial intelligence. So it comes to a point of more self-aware, like being aware of what's coming. And then the government should take the initiative of, okay, like I need to be aware of this. What happens when like when I give autonomy to a car? And then we also have to consider about the legal part of this, which you will, I believe, appreciate it. Because let's say an autonomous car crashed, like went into a car crash and like killed a human. Who is gonna defend this autonomous car? Well,
Who's I guess the that's the question of who holds the liability. If the person's not in control and the car makes its own decision and does something, is the person responsible? Is the maker, manufacturer, the technologist, the car itself, whatever it is? Interesting. Yeah. Fantastic points. What a wonderful conversation. I heard recently a line that seems to fit based where we have how we've gotten to this point in our conversation. That would you rather be right or would you rather be free? And I think that fundamentally is a question to look at in the AI space: is freedom
mm-hmm,
rather than being right. The freedom to do the wrong things forces us to recognize that we have a choice to make.
mm-hmm,
You can choose to be counterproductive, you can choose to be harmful, or you could choose to be productive and choose to be connective.
mm-hmm,
And that individual choice in use will be what the ultimate experience is, because that's going to work its way throughout the system. So
mm-hmm.
making good choices, and that's fundamentally human, isn't it?
Yes.
Yeah.
Oh, definitely, because we have to make, we have to take responsibility of the choices. And I believe when you make the decision and take the responsibility, then there comes the freedom, right?
Mm-hmm. Mm-hmm. Well, Merve, you are a wonderful guest. You are consulting out there. So anyone that's really interested in developing AI technologies or considering its potential application
Mm-hmm,
or deeper should try and connect with you. And you'd like to create some solutions out there. I'll give you the last word.
mm-hmm. Yes, exactly, Eric. I am currently focusing on how to more focus on the things that we can do with precision and like solve more deterministic problems with AI rather than going like generative and creating something cool. Let's first solve the mundane problems that we have and then scale companies with this solutions. That's gonna also make the employees happier, and then because they're gonna get rid of all the boring tasks. I believe not repeating when we are on a day to day. I would not like to repeat a solution. I don't want to solve the same problem twice. So I'm exactly there, and I don't want anyone to solve the same problem twice. So if we can make that in an AI system, which AI is more deterministic on solving rather than creating like generative in the generative space, because that's more like less probabilistic and you don't know where it's going. So when it comes to scaling up with concrete solutions with AI, if they have the data set, they can reach out to me, and then we can have a talk about like what it can bring and how AI can make a tangible impact for the companies or the constructs.
Perfect. Well, thank you so much for joining me. I'm Eric Postow of Holon Law Partners. Tune in next time.
Thank you.
I think that was pretty